So I will talk about the 5G and 6G and the AI, I think. And I go directly now to the main message here. And that's really that you need all of these things. These are really the things you need in order to drive your digitalization infrastructure, right? So you need the mobile networks, and these are evolving. So claiming from going from telephony to mobile broadband and now into advanced connectivity. And what do we mean by that then actually? It's, of course, it continues to be high performing, of course, but it's also differentiated. So you can program it in order to have different characteristics for different services, different slices that you can configure for different services with different properties. It will have more robustness, resilience, so you can run more mission-critical things on these infrastructures. Of course, then we come with 6G here, we will have continuous improvements in a lot of different areas. Then we have the cloud and the compute. And of course, we are now sort of using cloud compute for a lot of different things. And what is now discussed is, of course, the dependencies on these clouds and the need to have more control of your cloud environments. And then pushing that even further then to really go to the distributed compute. And I think it could be so that it is the AI workloads, the values of the AI services that will drive the investments also now for the edge compute. We have been talking about edge compute for so many years, right? But it has not really happened. And now it could be that there is a return on investment in order to build out much more distributed compute in order for your AI apps to work more fluently and more efficient and more secure, more robust, etc. And then, of course, the AI, we all see the development here. We have been working on this machine learning reasoning for many years. Then we had the breakthroughs here around the generative AI. And now we are seeing how we will have AI assistants, AI agents. We will have it in the AI robots, etc., around the corner. So the potential is, of course, enormous, and you need to get all of these things together, right? Focusing a little bit more on the networks, I think we can, of course, talk about 6G and so on, but realistically, what we do from now in the coming 10 years has to be on 5G. It's 2035 that you will have 6G networks a little bit more widely deployed, and we can't wait for 10 years. So it's all about now accelerating the use of the 5G network. You can do this in two different ways. You can, of course, sort of expand, scale sort of on top of the existing networks. And here we have a lot of different things happening. I think we are seeing that laptops are increasingly being 5G enabled, and you're using 5G on your laptops instead of Wi-Fi in many situations. The fixed wireless access is perhaps the biggest success you can claim when it comes to new services on 5G. Many of our customers now have more than 50% of the traffic in fixed wireless access. So it's an enormous growth. And a fixed wireless access user then consume, if a normal user is perhaps coming up to 1 gigabyte a day, 30 gigabyte per month, you can have 200-300 on the fixed wireless access user. So they consume, of course, much more traffic. And it's also a possibility, of course, to use higher frequencies if you have a good connection to different houses. And you can continue then to optimize here, of course, and we are seeing now how the AI apps is going to start to pick up, of course. The other dimension is really to try to build new networks for new customers, right? And here you can go to these different verticals, and you can think about providing for offices. And here I think it will take a lot of time to build sort of private networks for all of these different smaller offices. you should of course do that to a virtual slice. So you can have that served from the macro networks. And that will scale much faster, of course. But then you have all of these enterprise private networks, and I think in different cases now we see really how it is being established. If you would run a port, for example, you can't really do that without a good coverage for the port. That's sort of accepted now as some sort of table stakes. So in a lot of these situations, it actually is now coming to be default that you do need a 5G private network in order to run your operations. And then, of course, all the mission-critical networks, that is increasingly now interesting, thinking about the robustness in society, etc., for different crises, etc. So we are, of course, seeing these two things, and we are pushing forward together with our customers in order to expand the usage of the networks. Going to 6G, if we are now seeing the 5G being here, the digitalization of societies and industries, what really will be the step towards 6G? And it's extremely difficult to predict, of course, and we have been trying to do this for the previous generations, and we have been wrong all the time, right? We believed it would be something, and then it turned out to be something else that picks up. The fixed wireless access was not really on the radar when we designed 5G, and now that's suddenly the largest use case in terms of throughput through the networks. So what could it be? But I still think that it will be around the massive twinning, that everything will have a digital twin. We will have them for environments, like Ronnie showed, for cities, and we will have them for all different objects. We'll have their digital twin that is updated in real time, etc. And this digitalization is really sort of the framework in order to build services on top of this. Because if you can take the physical reality, get it into a digital representation, you can put compute power on that, and you can do this programmability of different things that you would like to control then in whatever industry, your home, society, etc. So I think it's something there around the cyber-physical continuum that we will look back on when we are looking at 6G in a few years. Then, of course, we have this fact that things take time. This is big numbers. There are sort of billions of mobile subscriptions there, and how they gradually then progress over time. And we are now here in 2020, beginning of 25 there, and then we are seeing the next 5 years, and you can see how the number of subscribers continue to increase. And currently, 4G is still growing, right? But that will start to decrease, and legacy technologies will also be less relevant, and then it will be dominated by 5G. And here we also have a lot of these energy consumption questions. I think we have taken significant steps on the energy efficiency from 4G to 5G. But if you still run the 4G networks, you still have that power consumption. So it's extremely important also to turn things off here and simplify the operator networks. But of course, you have a lot of legacy devices that you have difficulties always to turn off networks, right? In Sweden now, we are about to turn off the 2G. You haven't done that yet. So it's, of course, if you turn something off, then you can reduce your power consumption. And I think 6G will go a little bit further than 5G. I think we did a lot of things in 5G optimizing, so you can have less control channels, you can have longer sleep times, so when you're not transmitting any bits, you'll have zero power, basically. I think on the 6G, we are thinking about things like separating sort of the idle mode and the active mode, so you can optimize them separately. And by that, you can reduce even further when it comes to how much control signals, how much power you need to spend when you have sort of zero traffic in the networks. So you see there, it's a little small percentage there on the top there. The 6G will start to be deployed, and we will have devices, and we will start to use it there in 2030 time frame approximately. So what will it then be used for? And if you go back a few years, I think we all would say, oh, this is this immersive experiences, it is the AR, VR type of applications that will drive this. Now it's sort of obvious that it's the AI assistants and the AI workloads that will be coming first, because they are already here basically, right? And we will start to use our AI assistants much, much more. I do think that there is a combination of these two which are very interesting, because when you are sort of interacting with your AI assistant, the smartphone is perhaps not the optimum device. So you would like to interact with it in a different way. But these services will drive a lot of new traffic, I think. It will be more uplink, because you will be having cameras, you need to record, you need to analyze that, and you need to send these camera feeds, at least partly, to the edge in order to understand what the surroundings are. So you need a faster response time, because you would like to have a fluid conversation with your AI assistant. So there are also a lot of real-time requirements in this. And the XR glasses, AR glasses, has been a bit slow, right? I think you see excellent quality when you have the virtual reality glasses. But when you have the augmented glasses with see-through, it's not yet there, right? So we're still a few years out before these are really, really attractive. But there are this in between, I think, which is normal glasses with cameras that you can use, and use the uplink feeds from the cameras, and use that with your AI assistant. And then you will have the downlink will be more of a voice, perhaps a simple display or something. But this is much, much easier, I think, and these are already existing, and I think this will be the next thing that we will start to use, and that this will, of course, further drive the uptake of the use of your AI assistant, because it will be much so easier to have a dialogue with that and getting sort of guidance and information and etc. from this. And this will again put quite a lot of expectations on the networks. So for this to work, you really need to have a good network, and you really need to have built out 5G networks. You need really the mid-band coverage, you need the standalone, etc., right? And most likely you will need partly some edge compute to get this to really, really work. Then there is a lot of discussions among the industry, what is AI assistance and the use of the AI would lead to when it comes to the increase of traffic. And I think we are seeing that this will push traffic further. If you use your AI assistants, that will drive a lot of uplink traffic, and it will increase traffic in the networks. But of course, it could be a sort of I think our base scenario is that this will take off and everybody will start to use it. But of course, it could be even more accelerated, and it could sort of formally explode when all of us starts to use these AI assistants. But then, of course, there's also this possibility that you can go to more semantic communication, and you can compress parts of the content using AI, using generative AI. And that could sort of break the curves, perhaps. So on this new traffic coming from AI assistants, AI glasses type of workloads, I think it's interesting to see how detailed that information need to be. Is it enough that I walk on the street and there are a few cars on this side? You don't need to know exactly what kind of cars or something. these kind of compressions would of course be perhaps sufficient for your AI assistant to help you with things, right? But sometimes it needs to recognize a building, and then of course that needs to be transmitted with enough quality. And or if you want to place a virtual object, of course the virtual object could be, you don't need to render that in the source, you can transfer the properties of this virtual object, and that could be then rendered at the glasses, etc. So there is of course a possibility to use this technology also to increase the compression. But I think it's to believe that your Netflix movies should use this technology, that's a slow process to have the next MPEG codec and so on, and have that standardized. And I think we will see more efficient video codecs, of course. But it's take a long time before they are really getting and penetrating the market and being used. So the basic traffic growth that we see will continue. We will have traffic growth on top of that. But there is a question mark, how much of that could be even more efficient if you're just coding for an AI assistant on the other side, perhaps. So saying a few words about this cyber-physical continuum, or the cyber-physical world that we call it. And I think we have the same presentation, the same concept here from Deutsche Telekom as well. And this is really how I believe that you will see these things. There is a physical reality. There is a lot of information in the physical that you will collect with a lot of sensors. You will move all of that over to the digital side in order to create this digital representation. And when you have that digital representation, you can do all of these different services. You can do the augmented reality, or you can fly the drones, etc. And when you, on the digital side, understand what if you want to control something, you will actuate back. So you will send from the digital side out to the physical and control your robots or whatever you have there. And the 6G platform will, of course, be a key in order to do this in a robust and resilient way. So this is the overall vision, really. Then I would like to say something, and again, Deutsche Telekom alluded to this, and there was a question here around how to make this work in a multi-operator setting. Because we have this issue, right, that there is hundreds of operators, 3, 4 in every market, and then there are a few of these hyperscalers, CPaaS players, etc. And then there are developers on top of that would like to do something. And today, we have companies have solved this, if so you can send an SMS or something. So either you do something completely over the top and just ignore the fact that there are different operators below, or you go through, for example, Vonage, and then you have the possibility to send an SMS to a user, reminding on the next appointment with your dentist or whatever. Right? Then you can go to this Aduna structure, which is really the plumbing here. So connecting all the operator networks, making it possible then to expose things out of these networks, collect that and make that useful by the different players on top of here. So the developers can use the properties out of the networks without needing to bother about signing up with all the different operators. And we have now a significant set of telecom operators on board. In some markets, we have all the major operators, so it's possible to say that it's fully covered. But of course, this is far from enough. We need to get all operators into this in order to provide the full scale of this. And of course, it's easier if this is standardized, so all the different operators can sort of expose and take API calls in the same way. Standardization is ongoing, so the Camara standardization is making progress. But there's a lot of things you can do already with existing networks, again. We don't need to wait for new functionalities, a lot of possibilities to do with existing networks in this way. And what could this API be then? It could be sort of anything here from transporting data, of course, with different quality of service type of requests. We are back to that very basic thing. But it could also be sort of more metadata around the environment. So how would the network look like in the coming 1 second or something, or in the coming 100 meters? What will be the position of an object? But you can also think of that you could process and store that positioning data, right? So you are not delivering the position, you could deliver a fully trained AI model of this object to the applications, which you update continuously. So you don't just get the position, you get sort of all the physics around this object, and you can write your application on top of that. So there's a lot of richness that could be to be shown here, of course. And we have alluded to this simplification and a lot of the different options and things that we now, mistakes that were done in sort of the introduction of 5G. I think to have non-standalone and then standalone was not a smart thing, right? I think everybody realized that. So the proposal now is to keep the core networks. So you will evolve them. Yeah, and they have all the needed properties, we believe. So you can sort of continuously upgrade and make them more and more capable and addressing all the needs that we see on a 6G time frame. So, and then you have the 5G RAN working today, and then gradually you will have the 6G RAN, and then the 6G RAN should not be dependent on the 5G RAN, because then you can turn off 5G eventually and just run 6G. So you need to be smart around these things, to also think about how you are evolving these kind of things. So we should have a 6G standalone network, right, connecting to an evolution of the current core. I think this will take away a lot of the issues that we have had now. And we have the multi-rat spectrum sharing, so you can, in an existing frequency band, you can sort of gradually move from 5G to 6G. So when the number of 6G capable devices increases, you can then gradually then increase the percentage of the system that is used for 6G as your customers' base increase. And this will also make it easier then in the end to sunset other systems, because then you can run them on the new system and just keep a small fraction for your existing. If there's some remaining 5G customers, they could still be there on the same system. And then of course we have the carrier aggregation, and we would like to offer then a very more efficient carrier aggregation between different spectrum bands. So this is also an important thing. So finally then, standardization is starting, right? This is a picture from the meeting in South Korea. And it was like 800 presentations, 5 minutes each. So every company had the possibility to say a little bit what they believe that 6G should be and their favorite features or something like that. And now there's work going on in order to sort in this, and it will be decisions then in here now in June on how we should structure this 6G study item. What are the different things that we should work on in parallel, etc., in order to move forward in this 6G study item phase. So we will know more here fairly soon on what the different pieces will be. So yeah, that's it. Happy to take questions.